All right, so I think I first want to look at the graph, because sometimes they always ask you questions about the graph. What's the graph look like? Can you do domain and range? Because that's pretty basic. All right, so let's look at a basic sketch here. So radical means square root, so let's just take the square root function. Let's not necessarily, well, we may even do the cube root as well. So y equals a square root of x. Okay, so a basic square root function, all right, not moved or translated anywhere around the coordinate plane. What it's going to basically look like, just a little rough sketch here, is it will start at the origin, and then it's going to go up and to the right. Okay, up and to the right, little swoopy thing. All right, now rough sketch, so I did not draw that accurate. All right, because technically what? It could go up just a little bit and then shoot to the right really far, or it could go up really high before it shoots to the right, depending on what some extra numbers are around it. It can also move away from the origin, but for us, we just want to make sure that you know that the basic function, what it looks like. All right, from something like this, you should be able to calculate domain and range. We've been doing domain and range probably since Math 104. Okay, so domain is left to right. Okay, so looking at the graph, the first number on the x-axis, the first x number on the x-axis would be 0. All right, and then the graph goes forever and ever and ever to the right. Forever and ever to the right is a negative infinity down here. Okay, 0 is a solid dot right there, so that means it's included in our domain. So close bracket 0 all the way up to, why did I write negative infinity? I don't know. That's positive infinity. All the way up to positive infinity. Had a moment there. Okay, and then now you've got to think for range, you got to think y. So I'm still looking at the same thing, but I'm going to start down here at the bottom of the graph. All right, I'm going to go up on the y-axis. The first y value right there is 0. All right, because there's a x value of 0, there's a y value of 0 because it's the order pair 0, 0. All right, and then this goes up. Now, even though the way I drew it, it will not go out horizontally. What it's going to do is it's going to swoop and go up to the right, and then forever and ever and ever, as it's going to the right, it's also going up. All right, positive infinity's up there. So it starts at 0, 0 is included. So on this particular one, we also have 0 to infinity because positive infinity's up there. So just being able to, that's kind of a review from 104, but there's still, every now and then will ask you for domain and range randomly. Okay, now we're going to do a lot of square roots. We'll do some cube roots. We'll probably even do some fourth roots. All right, let's go ahead, and since we're doing basic sketches here, let's look at the basic sketch of the cube root of x. All right, now the way I think of this, or the way I try to remember it, is basically it's a square root graph that has a tail. Okay, again, we're doing a basic sketch, rough sketch, not moved away from the origin, so it's not translated left or right, up or down or anything. It goes right through the origin. All right, so think of it as, okay, it's the square root graph, so going this way, and then a tail that comes down like this. Okay, so it's a square root graph with a tail. And then again, if you've got your graphing calculator, you can look at it. It'd be a little bit more precise as opposed to a rough sketch with my hand drawn again. All right, does it go, how high up does it go before it goes to the right? How far down does it go before it goes to the left? All right, that sort of thing. Okay, now stop and think about this graph. There's no holes in it. I can draw it continuously from left to right. Okay, so the domain is negative infinity to positive infinity. Okay, because negative infinity is down here, positive infinity is down here. So our domain on this one, negative infinity to positive infinity. All right, range. All right, so again, regardless of how bad I hand sketched this, all right, yes, this is going to the left, but at the same time, it's also kind of going down. Same thing here. Yes, it's going to the right, but it's also going up. So again, range is going to be negative infinity all the way up to positive infinity. So my guess is on a written test, like in exam 3 or on the final exam, you will not have to sketch it or anything like that. But on the final exam, they could very definitely throw some type of graph at you. It wouldn't have to be a radical graph. It could be any of the graphs we've studied, piecewise, we've done rational functions, whatever, and they could then ask you to find domain or range. Okay? So more likely than not, if it's going to show up, it's going to show up on the final exam. Okay. All right. So, background there. Now, let's just make sure that we know everything we're supposed to know about, like square roots, vocabulary, what things are called. All right. If I have just a square root, like I take square root of a number, square root of 25, square root of 26. All right, for the most part, that denotes the positive square root. All right, sometimes we will call it a principal square root. So just a good old-fashioned square root sign, nothing in front of it or anything. Principal square root, positive square root. All right, if I put a negative in front of it, no matter what's underneath there, then that's going to be a negative square root. Yeah, negative square root. In case that my math lab does any type of vocab. All right, so let's take a kind of big one here. You're going to have a radical sign right there. Let's say you've got something underneath. We'll denote that by an A. All right, the part that is sitting underneath is called the radicand. The symbol, that right there, the symbol part, is the radical sign. And then if you want to refer to the entire expression here, so the square root of the entire expression, it's called a radical expression. Expression because there's no equal sign or anything like that. But in case, sometimes when they start these sections, they ask for some vocab words. All right, so then there's a nice set of little vocab words there. Now, some of these at the very, very beginning in this first section, it's going to be like you have done these. They're going to make sure the perfect square roots are going to come out really, really nice. All right, so if I wanted to look at some examples, all right, you're going to have to do maybe say square root of 25. All right, and at this point, I'm hoping that, this is really easy, right? What number multiplies together to be 25? So it's a principal square root. Answer is just going to be 5. I'll put them underneath here. All right, if you have a negative on the outside, like negative square root of 9, okay, you're going to do square root of 9 like we always have. That's going to be pretty simple. That's going to be a 3. Because there's a negative sign in front, then you're going to have a negative 3 as your answer. Now, in this first section, if you see a negative underneath, like say negative 4, underneath, okay, in this section, in this book, at this point, imaginary numbers have not been taught. Now, we all know imaginary numbers. You did imaginary numbers in Algebra 2 when you were in high school, so you know what they are. So, like, everybody in the room probably can tell me this is a 2i for a square root of a negative 4. However, in this first section, they are assuming you don't know anything about imaginary numbers. So what you're going to write down on this and on your graded homework is not a real number, which that's a true statement, because if I did write down 2i, that's an imaginary number. Okay, so us writing not a real number is an acceptable answer. So that's what you need to do in this very first section here. We will, I think, before the end of the semester get into some imaginary numbers, but not for a long, long time. They also expect you to be able to do decimals and fractions. So they will all be perfect square roots here at the beginning. So like 4 over a 9. Okay, square root of 4 over a 9. All right, there is a rule. And I'll go ahead and show it in red. Most of you are not going to implement the rule, but you can take a great big huge radical, break it up into 2 little radicals like that, which then lets you say, oh, this is going to be a 2/3. Okay, so most people don't write this step, especially when it's on real simple like this, and with square roots, they just don't do that. All right, now one with a decimal. So I can try to get these all on the same page here. Again, they're going to make it so that it's a perfect square root. So like 0.0064, Obviously, yes, you can put that in your calculator. However, I would hope that you could just look at that and go, okay, let's use a little bit of common sense here. If something times itself that's got to equal 0.0064, I know 64 is a perfect square root, which is going to be an 8. And if you remember how to multiply decimals, there are 4 places in the answer, so that means I need half as many in what I'm multiplying. So 0.08 times 0.08 is going to give you a 0.006, so 0.08. Those of you that cannot reason that through, all right, you will have your calculator. You can put it in. It's going to crank it out just fine for you. All right, so here at the beginning, that's the only thing they want you to do. They want you to be able to do perfect square roots. They want you to, if there's a negative under here, say it's not real. They want you to be able to do it with fractions, decimals, and nice little integers. Okay, so that's going to start out really nice. Okay, nice little review.